Hi students, today we are going to learn few questions from periodic classification. So first question, define the following terms: isoelectronic species, ionization energy. So for most of the questions which is asked in question paper, we have to write or support our answer from NCERT. So the first question is isoelectronic species. So isoelectronic species, the direct definition is given, which is the some atoms and ions which contain same number of electrons. We call them as isoelectronic species. Here they are not asking any examples, so we are not going to give. It is 1 mark question. Second question, ionization enthalpy. Ionization enthalpy, again, this is also a direct question. The energy required to remove an electron from an isolated gaseous atom in its ground state. Each and every word is important. It should be isolated gaseous atom and it should be in ground state also. So we have to write the exact statement. Next question, justify the following statement. The second ionization enthalpy of sodium is more than that of magnesium. So for this you can't get the direct answer from NCERT because this is application based question. So for this we have to first step we have to write the electronic configuration 2,8,1. Magnesium is 2,8,2. So what is ionization enthalpy? Energy required to remove one electron. Enthalpy, energy. Just now we discussed energy required to remove one electron from the neutral gaseous atom. So if I want to remove the first electron, it is first ionization energy. Here, if I remove here, it will become first ionization energy. And the second ionization enthalpy of sodium. See here, second, if I want to remove the second electron, it is in the stable configuration, 8 octet. So if I want to remove electron from this, it is very, very difficult. That's why it is more than that of magnesium. Like in the same way, the third ionization energy of magnesium will be higher because the first electron you can remove easily. The second electron also you can remove easily. The third electron, if I want to touch, it is again the stable octet configuration. So it needs more energy. So it is an application based question. So you can't directly, you can get it from NCERT, but still the concepts are there in NCERT. Okay, AlF6 is known, but BF6 is not. AlF6 is known, but BF6 minus is not. So for this question, this is also there in NCERT. The answer lies here. The first member, like boron and aluminium, they are comparing. So boron belongs to period number 2, aluminium belongs to period number 3. If principal quantum number is 2, the possible azimuthal quantum numbers are 0, 1. So the possibilities are 2, 0. So 2s is possible and 2p is possible. And if it is n is equal to 3, the azimuthal quantum numbers are 0, 1 and 2. So 3s, 3p and 3d. 3s, 3p and 3d. So these three are possible. So now you read this statement. This the first member of the group has only 4 valence orbital. So one p orbital will have 3 rooms or 3 orbitals. P will have, so it will have 4 availability, and the second members of the groups have 9 valence orbital. S will have 1, p orbital will have 3, d can have 5. 5 plus 3 plus 1, 9 orbitals we have. Here it is only 1 plus 3, 4 orbitals we have. 4 orbitals. So as the consequence of this, the maximum covalency of the first member of each group is 4. Only 4. And whereas the other members of the group can expand their valency shell to accommodate more than 4 pairs of electrons. That's why AlF6 is known, BF6 is not. Next question. Why Na2O is basic oxide and Cl2O7 is an acidic oxide? Again, coming to this question, we have two different answer for this. This is the exact question from NCRT. You can also write this since it is Na2O with water forms a strong base NaOH, and Cl2O7 with water it forms HClO4, which is acidic in nature. That you can check it with the help of litmus paper. This also can be written, but you can also write one more answer, which is the normal oxide formed by the element on extreme left is most basic, because when I see periodic table, left side mostly metals. So metallic oxides are basic in nature. We all know this. I told you to remember MOB. Metallic oxides are basic. Oxides are basic. So that's why Na2 is basic oxide, whereas Cl, chlorine, is present on the extreme left side, extreme left, extreme right side, and most acidic in nature. Okay. So next question. Account for the following statement. The electronegativity of any element is not constant. This is also there in NCRT. The electronegativity of any given element is not constant. It varies with depending on the element to which it is bound. So it depends on the element to which it is bound. It is not a constant value. So it is a 1 mark question. So you can write 1 line explanation. Next, the electron gain enthalpy of sulfur is more negative than that of oxygen. Again, this is also there in NCRT. So, whenever we talk about electron gain enthalpy, we have two exceptions. One is chlorine. Okay, so these two are the exceptions. Usual trend decreases. Down the group decreases, but when I go down, fluorine, after fluorine, chlorine is placed. So chlorine should have less electron gain enthalpy, but still chlorine has more, and sulfur is also having more electron gain enthalpy. So this is because the electron, see, this is electron gain enthalpy. Basically we are going to add one more electron to this oxygen, fluorine, chlorine. We are going to add one electron to this. So we have to write when an electron is added to oxygen or fluorine, the added electron goes to smaller n is equal to 2 small quantum level. So when n is equal to 2, it will suffer significant amount of repulsion from the other electrons present in this level. Why? Because we have very less size, n is equal to 2 only. So it will experience greater amount of repulsion. Since it is experiencing greater amount of repulsion, it will have less electron gain enthalpy. In the same way, when n is equal to 3, quantum level S, or chlorine or sulfur, the added electron occupies a larger region of space and the electron repulsion is much lesser. So they can ask you in any format, chlorine or sulfur. This is the explanation expected for this question. Next question, a cation is smaller than its parent atom. A cation is smaller than its parent atom because it has fewer electrons while its nuclear charge remains the same, or effective nuclear charge increases. It's correct. The size of the anion, they are talking about the size also. Size will be larger than that of parent atom because the addition of one more electron would result in the increased repulsion. So as anion will always have bigger size than neutral atom and the cation. So cation size is smaller because effective nuclear charge increases. Here, effective nuclear charge decreases. So I want all of you to read NCRT line by line to decode all this information. Thank you.